From SpaceX's early days to the fully reusable future they're chasing now, each new rocket pushed them further. So today we're breaking down every major SpaceX rocket from oldest to newest, explaining what each one was built to do, what it costs, and what makes them so legendary. Starting off with the rocket that built SpaceX's entire foundation in 2006 is the Falcon 1. Falcon 1 was SpaceX in its rawest form, a small two-stage rocket built to prove the company could reach orbit before the money ran out. Early on, Falcon 1 launches were advertised in the single-digit millions, and performance-wise it was capable of putting well under 2,000 pounds into low Earth orbit. This rocket wasn't built to handle the heavy payloads. Falcon 1 explains everything SpaceX becomes. In the early 2000s, SpaceX had no launch experience, no government contracts, and didn't have the luxury of slow progress. Every attempt was a company-level bet. Falcon 1 was designed to be simple enough to build fast, but capable enough to teach SpaceX about engines and all the details that decide whether the rocket is a failed science project or an actual launch vehicle. The defining feature of Falcon 1 was the learning curve. It forced SpaceX to figure out how to build rockets efficiently, manage real launch operations, handle countdown pressure, respond to failures quickly, and improve fast enough to stay in the game. Falcon 1 set SpaceX's personality by testing aggressively, fixing problems fast, and flying again. In the old aerospace world, rockets had long timelines, huge teams, and tiny changes. SpaceX did the opposite with tight engineering loops, fast rebuilds, and decisions made with survival in mind. In September 2008, Falcon 1 reached orbit, a historic milestone for a privately developed liquid-fueled rocket. Then, in July 2009, it flew SpaceX's first commercial payload to orbit, proving it wasn't just a demo, it could deliver. The Falcon 1 didn't scale. It didn't become a massive program because SpaceX quickly realized the real demand was bigger payloads, bigger contracts, and bigger missions. Falcon 1 was the spark, but SpaceX's growth would be the next rocket, one that could carry serious mass and eventually attempt something that used to sound impossible: landing and reusing the first stage of the rocket. Coming up next on SpaceX's timeline in 2010 is the Falcon 9. Falcon 9 is SpaceX's workhorse. This is the rocket that launches satellites, hauls cargo, carries astronauts, and runs Starlink like a conveyor belt. On SpaceX's standard pricing, a Falcon 9 launch sits around $74 million in their current payment plan. And on a fully expendable mission, it can deliver about 50,000 pounds to low Earth orbit, roughly the weight of a fully loaded semi-truck. The truth is that it isn't just a rocket, it's an operating system. SpaceX won by turning launches into a repeatable process. Reliability, standardization, manufacturing at scale, and ground multiple operations. The Falcon 9's design choices reflect that. It's a two-stage rocket burning kerosene and liquid oxygen, powered by Merlin engines. Using 9 of them in the first stage, clustering smaller engines simplifies manufacturing, enables engine capability in some cases, and lets you scale thrust without inventing a new monster engine. But the largest step was the decision to chase reusability. Most rockets light once, then throw away the biggest chunk and build another. At first, the recyclability idea sounded insane. A booster re-enters the atmosphere at ridiculous speed, gets slammed by heating and loads, then has to flip, slow down, guide itself, and land with precision. That's an entirely different kind of rocket. SpaceX attempted controlled descents, gathered data, improved guidance, strengthened structures, tuned engines for deep throttling, and kept trying until it worked. Then, in December 2015, Falcon 9 pulled off the first successful return and vertical landing of an orbital-class booster, landing back on land after completing its primary mission. It was proof that rockets didn't have to be disposable. After that, SpaceX took it a step further by landing at sea. Landing on a drone ship allows more payload to be carried while still recovering the booster. They're floating runways for rockets. Then came March 2017, when SpaceX launched a mission on the first ever reused orbital-class booster. Now, Falcon 9 has had multiple versions over the years, but the one that matters today is the final evolved form, Block 5, which is the production-grade Falcon 9, upgraded for higher reliability, faster refurbishment, and repeated flight. Think of the earlier versions as prototypes that built the path. and Block 5 as the mature model designed to fly again and again. Falcon 9 became the backbone of U.S. human spaceflight. In May 2020, Falcon 9 launched astronauts to orbit on Crew Dragon, marking the first crewed orbital launch from U.S. soil since the Space Shuttle era, and the first time a commercial company flew humans into orbit. Then there's Starlink, which Falcon 9 turned into a rhythm: launch, deploy, land, repeat. With that cadence, SpaceX can build and replace satellites faster than competitors can schedule launches, turning space logistics into real infrastructure. Falcon 9 changed spaceflight not just because it's powerful, but because it's repeatable. Fast forward to 2018, and we land on SpaceX's Falcon Heavy. Falcon Heavy is exactly what it sounds like. SpaceX took Falcon 9's first stage and bundled three together: a center core with two side boosters. At liftoff, 27 Merlin engines fire at once, giving it a serious presence. Performance-wise, Falcon Heavy is in a different class, capable of taking about 141,000 pounds to low Earth orbit in a fully expendable configuration, roughly the weight of about 35 full-size pickup trucks. A reusable mission is often cited around $97 million, which is remarkable for heavy lift capacity at a price far below what rockets in this class used to cost. Falcon Heavy's brilliance comes from its strategy. Rather than building an entirely new rocket from scratch, SpaceX scaled up Falcon 9's architecture, engines, and systems, allowing it to deliver heavy lift much faster by building on what already worked. Falcon Heavy introduced a new layer of operational complexity. With Falcon 9, you're recovering one booster. With Falcon Heavy, you might recover two or sometimes all three, depending on mission needs. And on high-energy missions, sending payloads deep into the solar system, SpaceX may choose to expend the center core to maximize performance. Falcon Heavy's most iconic debut was its first flight in February 2018, when it launched a Tesla Roadster into space. That mission served as not only an engineering demonstration, but a public statement. The Falcon Heavy quickly became a serious tool for deep space and national security missions. NASA launched the Psyche mission on Falcon Heavy in October of 2023, sending a spacecraft toward a metal-rich asteroid, a mission profile that demands high energy and reliable performance. And in October 2024, Falcon Heavy launched NASA's Europa Clipper, a massive planetary mission headed to Jupiter's icy moon Europa, again showing Falcon Heavy is a real interplanetary launcher. It's the rocket you pick when Falcon 9 can't close the deal, but you still want SpaceX's reliability, cadence, and cost advantage. And finally, beginning in 2023, SpaceX introduced its most ambitious system yet: Starship and Super Heavy. Starship isn't just the next rocket, it represents SpaceX rethinking what a rocket can be. Falcon 9 and Falcon Heavy proved the first stage could be recovered and reused, and Starship extends that idea to the entire system. Both the booster and the ship are designed to return and fly again as a core objective, and the numbers reflect how extreme this is. SpaceX states Starship is designed to carry up to 150 metric tons to orbit in fully reusable form, and up to 250 metric tons in expendable mode. That's roughly the weight of a 2,800 square foot one-story house. Price is tricky because Starship isn't commercially priced the same way Falcon 9 is. It's still in development and test flight mode. But SpaceX's stated ambition is clear. They want Starship launches to eventually cost a few $1 million each, which would make space easily accessible. The Starship exists because Falcon 9 can't cheaply deliver massive payloads in one go. It can't make in-orbit refueling normal. It can't move huge amounts of cargo frequently enough to build real infrastructure on the Moon or Mars. Starship is designed for that kind of future, where spaceflight becomes a supply chain. The vehicle itself is a philosophical shift. Starship is built around methane and liquid oxygen and powered by Raptor engines. The propellant choice matters because methane is a practical path toward eventual refueling concepts, and because the whole architecture is aimed at rapid turnaround and scaling. The system is designed to be caught and recovered instead of using landing legs and pads. SpaceX plans to catch the booster with the launch tower's mechanical arms, often called the chopsticks. Starship's milestones have been coming in waves because this program is about iterative progress. The most headline-grabbing moment came on October 13, 2024, during Starship's fifth integrated flight test when SpaceX successfully caught the Super Heavy booster with the tower's mechanical arms for the first time. From there, the tests kept tightening the loop. By August 26, 2025, Starship's 10th flight test hit major goals, like deploying Starlink simulator payloads and achieving a controlled splashdown profile after re-entry. A big signal that Starship was learning how to behave like an operational vehicle. What makes Starship different isn't just its size, it's what it enables. With 150 tons of fully reusable lift capacity, missions like launching massive station modules, deploying large telescope components, moving cargo in bulk, and refueling in orbit become far simpler without relying on complex multi-rocket setups. And that's why Starship ties directly into big future plans. NASA's Artemis program selected a Starship-based lander concept for lunar missions. SpaceX wants to use Starship to expand Starlink dramatically, and Elon Musk's long-term vision is Mars. Starship is the bet that the bottleneck in space isn't engineering talent, it's transportation cost and flight rate. If Starship becomes truly reusable at scale, it's not just a new rocket, it's a new economic reality for spaceflight. Overall, SpaceX's rocket timeline is one clean evolution. Falcon 1 proved they could reach orbit. Falcon 9 made frequent flight and booster reuse real. Falcon Heavy expanded their reach into serious heavy lift and deep space missions. And Starship is the end game, the system designed to make space transport feel like an industry instead of an event. Thanks for watching. Comment below which SpaceX rocket you think is the most impressive, and what aerospace topic you want next. And if you enjoyed this breakdown, consider subscribing for more stories from the skies and beyond.